Hello, this is a walkthrough for the WJEC Summer 2023 Paper 1 Higher Paper. This is a non-calculator question paper. There's 80 marks available and we've got an hour and 45 minutes or 105 minutes to complete those questions. So more than a minute for every mark that's available. If you turn to page 2, you'll see that there are a number of equations there that might be useful. You've got the quadratic equation towards the bottom. You've got the sine cosine rule and the area of a triangle rule, volume and surface area of cones and spheres, volume of a prism and the area of a trapezium, as well as some explanation of annual equivalent rate. So be aware that they're there, they may come in useful. On to question 1. Okay, so just zooming in a little bit. So question 1 says translate the shape below, shown below, using the column vector -1, 7. -1, 7 means 1 left and 7 up. And the best way to do this is to pick a corner of your shape. So I'm going to pick the bottom left hand corner here of the shape, and I'm going to change colours slightly just to make it more obvious what we're doing. I'm going to move that corner 1 to the left and 7 up. That's 1 to the left, and then 1, 2, 3, 4, 5, 6, 7 up, and I'm going to put a new cross there. Now I've just got to redraw my shape from that corner. So it's an L shape, and the bottom left is going to start here, and it's 3 along the bottom, so I need to go 3 along the bottom here, 1 square up. On the left hand side it's 1, 2, 3, 4, 5 tall, so 1, 2, 3, 4, 5 tall. It's 1 across the top, and it's just 1 wide all the way into that L shape. Now I've done mine freehand there, but I would recommend that you use a ruler for this because it'll look way neater. Okay, and then on part 2 it says write down the column vector that will reverse the translation in part A. In other words, if we go 1 left and 7 up, when we're reversing that we need to go 1 right and 7 down. So our vector will be 1 right is 1 and 7 down will be -7. And that's answered question 1. Let's move on to question 2. Question 2. Express 675 as a product of its prime factors in index form. And we need to start off using a factor tree. And this is an upside down tree, if you like. 2 branches. I want 2 numbers that multiply to give 675. This is a non-calculator paper, so I can't use calculator here to help me. So I'm looking at a number I can divide into 675, and as it divides, as it has got a 5 at the end, it will definitely divide by 5. So I'm just going to do long division here, or the bus stop method. 5 into 675. 5 into 6 will go once, remainder 1. 5 into 17 will go 3 times, remainder 2. And 5 into 25 will go 5 times. So I've got 5 on one side and 1, 3, 5 the other. Now we're looking for prime factors. Are either of those prime numbers? Well, the prime numbers are the numbers that will only divide by 1 and themselves. They don't include 1. So 2 is, that's the only even prime number, so I only need to check odd numbers now. 3, 5, 7, 9 does not because it divides by 3, 11, 13, 15 isn't because it divides by 3 and 5, 17, 19 is. I'm going to stop there because I don't think we'll need anything higher than that. So are either of the 2 numbers, the 5 or the 135, prime? Well, yes, 5 is. So if I find a prime number, I circle and I stop. I don't need to do any more with that 5. Coming over to the 135 though, that isn't a prime number. It's too big, but also it's got a 5 at the end, so again it divides by 5. So I'm going to do what I've just done. 5 into 1, 3, 5. It won't go into 1. it will go twice into 13 with 3 left over, and then 7 into 35. So it's 27 is one number, and the other number is 5. So we've got 5 times 27 gives me 135. 5 is a prime number again, it's the same number, but 27 will divide by, I know that will divide by 3, don't I? So that's not a prime number. 3 times by 9 gives me 27. 3 is a prime number, but 9 isn't. So 9 can be divided, well, it's 3 times 3. Both are prime numbers, and we've now found all the prime numbers. So we've got the prime factors. What we need to now say is 675 equals, and I'm sticking them in size order, 3 times 3 times 3, and then 2 5s, 5 times 5. We've got it as prime factors now, but we need to put it in index form. So we rewrite that as 3 to the 3, because there's 3 3's there, so 3 cubed times by, and 2 5s means I've got 5 squared. Now it is in index form. Okay, moving on to the second part. So it doesn't actually refer to the first part in this, although it's a similar thing. It says 360 can be expressed as a product of its prime factors in index form as 2 cubed times 3 squared times 5. What is the smallest whole number that 360 can be multiplied to give a square number? Now a square number has to have all these prime numbers raised to an even power. Okay, so if it's not an even power, I need to multiply it by another one to increase it. So 2 cubed is not an even power, so I need to multiply by an extra 2, because that would make that 2 to the 4. That's even. 3 squared is okay, because that is an even power, but 5 is not. There's a missing 1 that we don't normally write in there, so I need to multiply by another 5, because that will make it 5 squared. Now all the powers are even. It's a square number, the total value. So I need to multiply by the 2 and the 5, and multiplying by 2 and 5 is the same as multiplying by 10. So the smallest whole number 360 can be multiplied by to give a square number is 10. Okay. Moving on. There's a multi-choice questions here. So for question 3, simplify each of the following, circle your answer in each case. M to the 4 times M to the 3 is just M to the 4 plus 3. When we're multiplying these indices, we add the powers. So that is M to the 7, which is that one there. And M to the 15 over M to the 5, when we're dividing these indices, we do subtraction. So 15 take away 5, that's M to the 10, which is there. Okay, part B says write down an expression for the nth term of the following sequence. So we need to think about what it's going up each time. So what is it jumping each time? This is jumping up 7 each time there, 7 again. I'm checking to make sure it does actually do the same thing every time, but it does go up 7 each time. The next number would be 32. It's not actually asked us for that, but you've given you a space just in case you wanted to write it down. Well, the plus 7 means it's like the 7 times table, so it goes up in 7, so 7n is what I'd write down, but this isn't the 7 times table, so I need to adjust it slightly. If I go back 7 from here, I end up at negative 3, and so what I've done is I've adjusted by minus 3. Okay. List all of the integers that satisfy the following inequality. 13 is less than 2n, reading this the better way, we normally read this from the middle, so 2n is greater than 13 and less than 16. So we want integers, those are whole numbers. So if I change the 2n to n, I'd have to divide by 2 to do that. So if I divide the numbers by 2 now, I've got 13 divided by 2 is 6.5 and 19 divided by 2 is 9.5. So I want all the integers, the whole numbers, between 6.5 and 9.5. Well, 7 is greater than 6.5 and less than 9.5, so is 8, so is 9, but when we got to 10, that's bigger than 9.5, so that would not be included. So the answer is 7, 8, 9. That was the last question, wasn't it? Okay, so the next question is asking us to construct, first of all, an angle of 60 degrees, and then later it's asking us to construct a 90-degree angle. Okay, I'm going to zoom in on each of these questions to try and show you, but you will need to use a compass here. Now, I haven't got a compass I can easily draw with online, but I will attempt to do it, but obviously yours should be neater than I can possibly manage. Okay, so we're trying to construct a 60-degree angle at point B. That means if I think about my line, I'm just going to draw out, first of all, a little guide to make sure I don't get confused. So an angle of 60 degrees at B will be something like that, won't it? Okay, and that angle there will need to be 60 degrees. So what I'm first of all going to do is I'm going to get my compass and put it at B. Where that X is, I'm going to stick the point of my compass. I'm going to stretch my compass out to roughly halfway along AB, but it doesn't really matter exactly where, just roughly halfway. I'm going to put an arc there now from B to this point here, and then I'm going to draw a curve, something like that. Okay, I've drawn that freehand, so it's not very accurate, but it suffices for now. Next, I take my compass, I don't change the size of this, and I go to this point, and I'm going to draw a curve the other way. So what I've got is, I've got a curve going this way, something like that. Okay, and what I've now done is I've constructed what would be an equilateral triangle where all three sides from here to here is the same length as there to there, and also from B to that point. Okay, so if I now draw a line from B up to that point, obviously you would use a ruler. That line there would produce me a 60-degree angle. Okay, let's move on to the next question. Using similar thing, we're going to now construct a point that's 90 degrees. It says R is a point on the line LM. Using only a ruler and a pair of compasses, construct an angle of 90 degrees at point R. So I'm going to take my compass, I'm going to mark where R is. I'm making it really clear. If I can't see it clearly, I put an X there. I'm going to put my compass point there, and I'm going to stretch my compass out in the direction of L, but I'm not going to quite get to L. I'm going to put a mark here, and rather than drawing a full circle all the way round, I'm going to turn round and I'm going to put another arc, the other side of the arc there. Now those two marks I've made are equidistant or equal distances from R. Now I'm going to get my compass again. I'm going to mark on the right hand side here where I've just put that mark. I'm putting another X now. I'm going to put my compass here. I'm going to stretch it a little bit beyond, let me just zoom in a little bit, a little bit beyond R. Okay, so I want to draw a curve in something like this. Okay, and then I'm going to not change the size of that compass, and I'm going to take it to the other end at L, and now I'm going to draw a similar arc. Okay, and it's going to come round something like this. Now I haven't stretched this one far enough, so it should go like that. They should cross. I'm going to get my ruler and I'm going to draw from this point to this point. So I'm going to draw a line going down like that, right the way through, and that should be a 90-degree angle, a perpendicular to LM. Okay. Question 4. Part C now. So that was question 4. This is part C now. It's another one using only a ruler and a pair of compasses. Construct a perpendicular line from the point P to the line XY. So we've got to draw a 90-degree angle to C. Okay, I think I might have zoomed in on this one. Yeah, here we go. So I get my compasses and I'm going to draw a line through P at 90 degrees. So really what I'm looking for is something like that, where that is a 90-degree angle. I'll just delete that again and we'll construct it now. Okay, so I put my compass first of all on P and I stretch it probably towards X but not quite hitting X. Okay, so just a bit short. I've got an arc there and I'm going to then also turn it round and continue that arc, and I'm going to cut through here, something like that. Okay, so I've now constructed 2 points that are the same distance from P on that line. Now I'm going to take my compass to each of those points. I'm going to the right hand side of it first and I'm going to put a cross there. I'm going to stick my compass point in there and I'm going to go halfway to the other point roughly, and I'm going to draw an arc like this, right? I'm going to go something like this. I'm not drawing that very well, so I'm going to draw it something like this. Okay, and then I'm going to go to the other point without changing the size of my compass stretch, and I'm going to draw the arc to the other side. This one coming from this point, obviously. I've drawn that arc, and now I've got 2 arcs that cross, and I'm sure you can guess that I'm going to take my ruler and I'm going to draw a line all the way from one point to the other, and you should find out that that lines up with P, and that gives me a 90-degree angle there, which is perpendicular line. It is important to point out that on all those 3 questions, you really do need to make sure you leave the construction lines in. Do not be tempted to rub them out, because I've asked you to construct. You won't get the marks unless you actually leave those constructions in. They need to see how you've done that. Question 5. So in this question, it's saying that you're going to get extra marks here for the quality of your organisation, communication and accuracy in writing. And you can see at the bottom right we've got 2 OCW marks, if I just zoom in here, and that's for just laying it out clearly, making sure you put units in, and bullet pointing what you're doing. So the question actually says the shape below consists of a semicircle attached to one side of a right angled triangle. Angle ABC equals 90 degrees, that's this point here, that's 90 degrees. AB equals 8 centimetres and BC equals 6 centimetres. BC is the diameter of the semicircle. Calculate the perimeter of the shape. You must show all your working. It says you've got to use pi equals 3.14, so we haven't got a calculator, so obviously that's important that we use that. Hopefully the calculations are not going to be too tricky. So we've got 3 parts of this. We've got AB, then the curve from B to C, and then from C to A is another straight line. I know AB, so that's fine. If I'm trying to find out BC, I need to know the circumference of the full circle. So circumference is equal to pi times the diameter, pi d. And in this case, we know that pi is 3.14, and we're timesing that by the diameter, which is 6. Okay, so we can work that out, and that would give me, difficult to do, so I probably will do some little calculations. So I'm going over here where I've got a little bit of space, and I'm going to first of all calculate 314 times by 6, and I'll put the decimal places in afterwards. So using the box method, that will be 300 and another 10 and another 4, which is 314, and we're going to times that by 6. So I have got 6 times 3 is 18, and there's 2 zeros. 6 times 10 easy, it's 60, and 6 times 4 is 24. Adding those up, I should get, let's do it properly, 1800 60, 24, 4, 8, 8, 1. So 1884 is 314 times 6. So 3.14 times 6 is going to be 18.84, 2 decimal places in there. So we know that value there is the circumference, but we only want half of that because this is only half of a circle. So 18.84 divided by 2, which is 9.42. Now, the one thing we haven't done really is we haven't really started to get those OCW marks. Although we've shown working, we haven't done it in really very well laid out way. So we might write, first of all, something like perimeter equals AB, the straight line, plus BC curve plus CA. And we know that AB, we said, was 8 centimeters. And now we're trying to work out what CB curve is. The curve CB is equal to 3.14 times by 6, and we've divided it by 2, so that we worked out to be 9.42. We've shown the working there. As long as I've shown it and I've explained in my working what I'm doing, I should be okay. And that's, we've got to remember that that's in centimeters. Okay, so it's important to show the units there. The final bit I've got to work out is the length AB. Now AB is part of a triangle, isn't it? So if I draw a little diagram here and I say AC and B is here, it's a right angle triangle. I know that that's 8 and that's 6, and so I should be able to use Pythagoras to work out what that side there AC is. So AC is the square root of the sum of the two others squared. So 6 squared plus 8 squared, which is the square root of 36 plus 64. That's 100, isn't it? So the square root of 100, which is 10 centimeters. Now I'm going to underline that bit, and I'm going to underline the other bits as well, because those are the important bits. So we've now got our 3 lengths, and finally perimeter is equal to 8 plus 9.42 plus 10, which is equal to, and you could use the column method to work that out, but you might be able to work out that's 18 plus 9.42, which is 27.42 centimeters. Okay, so I've laid it all out, and I think that that's more than sufficient to get the marks. I think probably I've overdone that, but the calculation should be like that. Okay, let's move on. Question 6. 2 time periods. Okay, so it says 2 time periods are measured as 4 hours 40 minutes and 2 hours 50 minutes. Each measurement is correct to the nearest 10 minutes. Okay, so that could be, this is like upper and lower bounds, isn't it? So to the nearest 10 minutes, the lowest, we can work out the lowest, and let's just see what the question says. It says, what is the least possible sum of these 2 time periods? Well, I want the lowest amount for each of those 2 time periods. So the lowest amount, 4 hours and 50 minutes, would be, if I take the 10 minutes and half it and come down 5 minutes, so 4 hours and 35 minutes would possibly round up to 4 hours 40 minutes, okay, and 2 hours 45 minutes would round up to 2 hours 50 minutes. Any lower than that and it would round down. Okay, correct to the nearest 10 minutes, that's correct. What is the least possible sum is I need to add those 2 together. So I want 4 hours 35 minutes plus 2 hours 45 minutes. 4 plus 2 is 6 hours, and 45 plus 35 is equal to 80 minutes, and that's 1 hour 20 minutes, and by combining these two I get total 7 hours 20 minutes. There's different ways of doing it. You could convert them all to minutes, but I think that would be a little bit harder. Question 7. It's looking like it is a probability question, isn't it? So it says Whitney walks, cycles or travels on the bus to work each day. On any randomly chosen day, the probability that she walks to work is 0.25, and we can see that that is featured here. Okay, walking is 0.25. The probability that she cycles to work is 0.45, and at work the probability that there will be a fire drill on any given randomly chosen day is 0.04. So 0.04 is the chance of having a fire drill, and that appears whether we walk, cycle or bus. That doesn't have any impact at all on the whether there's a fire drill or not. And it wants us to complete the table. Now there's a few blanks here. They haven't shown us the probability of going on a bus, and there's only 3 ways you can get to work, and that's by walking or cycling or bus. So the total of those 0.25, 0.45 and this one must add up to 1. So 0.25 and 0.45 gives me 0.7. So left over is 0.3. 1 minus 0.7 is 0.3. So that goes in here. Also, fire drill is slightly different here because we've got several branches all the same. So if we just concentrate on the top one to begin with, this one and this one must add up to give 1, because either there will be a fire drill or there won't be a fire drill. So 1 take away 0.04, be careful you don't put 0.6 because it's actually 0.96. Okay, 0.96 and 0.04 would give you 1, and that's repeated in the other blanks below because the probabilities are the same with the fire drill all the way through. So we've now completed the tree diagram, and that's worth 3 marks. Okay, now they're going to ask us a question about that tree diagram. It says, so I'll move up a little bit, on a randomly chosen day, what is the probability that Whitney walks to work? So she walks to work, I'm just going to change colour, she walks to work and there is a fire drill. So she needs to walk to work and then there has to be a fire drill. So the route we're taking is this one. Okay, so I need to combine the probability of walking to work, 0.25, and the probability of there being a fire drill. And we don't add as we're going across. Whenever we go across, because this is one thing and another, we are multiplying 0.25 times by 0.04. Now 0.25 is a quarter, so I need to divide 0.04 by a quarter, or sorry, I need to take a quarter of 0.04 or divide it by 4. 0.04 divided by 4 is 0.01. And that's the answer there. So there's 2 marks for that, probably 1 mark for that and 1 mark for the answer. This question is talking about measurements of lengths and things like that. Okay, so we've got in the following formula, each measurement of length is represented by a letter. So D is a length, R is a length, W is a length. And if I've got 4 lots of a length plus 1 length minus 2 lots of a length, those are all lengths. That's a length, that's a length, and that's a length. So adding them all up together will give me another length. So that's why length is here. So if I've got the next one, I've got a length, W is a length, and then in the bracket I've got a length plus a length plus a length. Well, that's just a length times by a length. That's going to be a length squared Well, that's like centimetres squared, isn't it? That's a length times by a length to work out an area. One length times by another length gives me an area. So that is area. Okay, so we need to put in area here because it says either a length, an area, or a volume. Okay. So the next one, I've got a length cubed. Well, that's a volume, isn't it? Centimetres cubed. Sorry, cubed. That's a volume. And I've got 3.14 times by another length. Okay, well, that will just be a length, won't it? A number times by a length is a length. Can I add a volume and a length together? Well, they're not the same things, are they, at all? So we will put none for that because it's given us that option of none there. Width cubed is a volume, centimetres cubed, over centimetres squared is an area. Centimetres cubed divided by centimetres squared will give me centimetres only. So that is a length. (3.14) times by r cubed. Well, it's 3 dimensions, so that's volume. And we're taking away, there's 3 lengths multiplied together, so that's another volume. So a volume take away volume is another volume. And then finally, we've got 4 times a length squared. Well, we can think of that as centimetres squared, an area, over a length, which is centimetres. So that's just going to be centimetres or a length. Next question, we've got some questions on standard form here. These are numbers expressed something like 2.3 times by 10 to the 9. It's this format, or we might have one that is 4.2 times by 10 to the negative 7. Okay, big one, small number. Okay, so expressing 0.076 in standard form means the first number has to be a number between, so this number here has to be a number between 1 and 10. So I'm going to take the digits that I've got there. I'm not changing the order of the digits, but I've got 7.6. If I take the 76 that's in that number, I've got 7.6 as the number using those digits between 1 and 10. Then I want times 10 to the, and to get that to 0.0076, from 0.0076 to 7.6, I'm moving this decimal place really 1, 2, 3 places. So it's moved 3 places, but this is a small number. So with the small number, we have to have a negative power. And that's my answer. Part B is asking us to multiply 2 numbers that are given in standard form. Okay, well, I can remove the brackets here and really write it as times 10 to the 17 times by 2 times 10 to the negative 12. That's the same thing. Bob Mass does not affect it, so we don't really need the brackets. I can also change the order so that I've got the numbers next to each other. So 3 times 2 times by 10 to the 17 times 10 to the negative 12. And I can just do 3 times 2 is 6. And then if I'm multiplying 2 things with powers, I can use indices rules and I can just add the powers together. 17 plus negative 12 is positive 5, so it's times 10 to the 5. It says to give my answer in standard form. This is already in standard form, so that's the answer. So part C says calculate the value of 2.3 times 10 to the 4 plus 5 times 10 to the negative 5 times 10 to the 3. This is not a multiply, so I need to treat these differently. The easiest way is to convert these to normal numbers, add them together, and then convert them back to standard form at the end. So 2.3 by 10 to the 4 is 2, and then I need to put in 3 bigger decimal places. So the 3 is 1 decimal place. I need 1, 2, 3 zeros in there to make sure it's the right size. To that, I'm going to add 5 times 10 to the 3, so that's that one. 5 times 10 to the 3 will go to a 5, and it's power of 3, so it's 1, 2, 3 zeros. So I need to add 23,000 plus 5,000, and that's fairly easy, it's 28,000. However, we've not quite given our answer in standard form, so I need to rewrite that as 2.8 by 10 to the 1, 2, 3, 4 decimal places. It's a big number, so that is the answer there, 2.8 by 10 to the 4. Question 10. This is says xy is a tangent to a circle, centre O at point A. At the point A, AYO is equal to 54 degrees. Okay, so let's have a look. So xy is the tangent, and what we're trying to work out is what percentage of the whole circle is shaded. Well, if I just concentrate and not worry too much about the 54 degrees at the moment, will that help us? In fact, we know that that meets the tangent at 90 degrees there. Okay, so a tangent and a radius always meet at 90 degrees on a circle. So if that's the case, this is a right angle triangle, and angles in a triangle add up to 180, so I should be able to work out that angle there. So I need to do 54 plus 90, that is 144, and then I want to do 180 minus 144, and that gives me 36 degrees. So that angle there is 36 degrees, and if I'm working out the area of this sector, that is a fraction of the whole circle. It is 36 degrees out of the total 360 degrees in a full turn, and the area of a circle, a full circle, will be pi times radius squared, or pi r squared. We know, do we know the radius? No, it doesn't want us to work it out, does it? It wants us to know what the percentage is. So to turn that fraction into a percentage, I need to multiply by 100. So I've got 36 times by 100 over 360. Well, that will give me 3600 over 360, and I can just cancel 2 zeros off. 360 divided by 36 is 10, so the answer is 10%. Part B says, what tangent property of circles did you use in order to answer part A? Okay, so it's just one property, and it was the fact that the tangent and radius meet at 90 degrees. You could say perpendicular if you'd rather, or at right angles, as long as that idea is there. Question 11. Question 11 says, given that y is inversely proportional to x, show that and that y equals 0.2 and x equals 160, find an expression for y in terms of x. So we know y is inversely proportional to x. That leads us to y equals a constant over x. We now know that y equals 0.2 when x is 160, so I can put those values into the equation. I've got 0.2 is equal to k over 160, and by rearranging that, I've got k is equal to times by 160, 0.2 by 160. 2 times 160 would give me 320, so that's 32. Therefore k is equal to 32, and then going back to the equation here, what we've got is, our equation is y is equal to 32 over x, and that is my answer, y equals 32 over x. Then it says, use the expression you found in part A to complete the following table. Well, I don't need the initial part of the question, so I'm just going to zoom in a little bit here. So we've got my equation above. So if x is 128, y will be 32 over 128. That's not easy to do, but I'm going to cancel the fraction down. I'm going to half the top and the bottom. That's 16 over 64. I'm going to half again. That's 8 over 32. And I can divide both of those by 8, like I've spotted now. And that is 1 over 4. So that is 0.25. Okay. The next bit gives us the y value, but doesn't give it, and we have to work out the x value. So we go back to this formula again, and we put in the y value as 0.8, and we say that's equal to 32 over x. And I need to find out what x is now. So I probably need to do a little bit of rearranging here. I'm going to multiply by x first of all. 0.8 x is equal to 32. And then after I've multiplied by x, I'm going to divide by 0.8. So x is equal to 32 over 0.8. I can change that to 320 over 8, which makes it a bit easier because I haven't got any decimals in there. And 320 divided by 8, well, 32 divided by 8 is 4, so 320 divided by 8 is 40. So my answer in here is 40. The sphere has a diameter of 6 centimeters, and a cone has a base radius of 10 centimeters and a height of 9 centimeters. Find the ratio of the volume of the sphere to the volume of the cone. Now, for these different things, we've got the volumes at the front. At the front of the booklet, we'll give you the formula for the volumes of a sphere. So a volume of a sphere is equal to 4/3 pi r cubed. So you just need to go to the front of the booklet and it will tell you that. And the volume of the cone is equal to 1/3 pi r squared times by height. Okay, so I need to put all the values in to work this out now. So slightly lower down the page. So for the sphere, I've got volume of the sphere is equal to 4/3 times by pi times by, and the radius is not 6, is it? The diameter is 6, the radius is 3 centimeters. So times by 3 cubed. And on the right hand side, the cone, the volume of the cone, will be equal to 1/3 pi times by the radius squared. Well, the radius is 10 centimeters here, so I've got 10 squared times by 9. Okay, it wants us to find the ratio of the volume of the sphere to the volume of the cone. I probably want to try and simplify that a little bit. So I've got 4/3 times by, well, 3 cubed is 27 pi, but also I can divide by 3 here, so 27 divided by 3 is 9, and then 4 times 9 will be 36. So I've got 36 pi on this side, and this one will simplify to, well, we've got 1/3 times 10 squared, which is 100, times by 9 times by pi. 9 divided by 3 is 3, and then times by 100 is 300, so that's 300 pi. So the ratio that we've got is 36 pi to 300 pi. But I can take the pi out because it's the same on both sides of the ratio. So 36 to 300, and then I can divide both by 6. So 36 divided by 6 is 6, and 300 divided by 6 will give you 50. And I can't go any further. Oh yes, they're both even numbers. I can half again, can't I? So that will be 3, and that will be 25. And now I've simplified it as much as possible, and my answer is 3 to 25. Triangle ABC is a right-angled triangle. The area of the triangle is 0.75 centimeters squared. So A equals 0.75 meters squared. Okay. Show that 16 squared minus 8x minus 3 is equal to 0. Well, it's told us some more information in the diagram here. It's showing that we've got a height of 4x and a length of 2x minus 1. But the area of a triangle is going to be area equals half of the base times by the height. So the base times the height will be 2x minus 1 times by 4x. So I need to multiply that bit out, but I also know the answer, the area, is actually given as 0.75. So I'm replacing the A with 0.75, and now I need to multiply out the right hand side. So 0.75 equals, and 2x minus 1 times by 4x, multiplying these two first of all. 2x times 4x will give me 2x times by 4x will give me 8x squared. That's that times that. And then 4x times by negative 1 will give me negative 4x. So I want half of 8x squared minus 4x on the right. Half of 8x squared will be 4x squared, and half of minus 4x will give me minus 2x. So I've got 0.75 is equal to 4x squared minus 2x. And this equation is equal to 0. So if I get rid of the 0.75 on this side, I've got 0 by taking 0.75 away. 0 equals 4x squared minus 2x minus 0.75. But it wants these numbers to be 16. So to make that 4x squared, let's go down the bottom now and rewrite that a little bit neater. So we've got 4x squared minus 2x minus 0.75 is equal to 0. I've now got it the same way round as here. But that's 16 there, and we've got 4 here. So if I times all of the thing by 4, I get 16x squared. 2 times 4 is 8x, and then 4 times 0.75. That 2 times 0.75 is 1.5, so 4 times it will be 3, which equals 0, and that is the same as we've got here. Okay, so 3 marks for that one. Part B. Solve the equation 16x squared minus 8x minus 3 equals 0. And we've got to use an algebraic method. This is the formula in the previous question, but we're not going to really need to use much more than this. Okay, so we've got to solve it. First of all, we're going to try and factorise it. Okay, we're not allowed to use the quadratic formula. We haven't got a calculator, so that will be really difficult. So I've got 16x squared minus 8x minus 3 equals 0. And I'm going to try and put these into 2 brackets and make it equal to 0. Now, there are several ways that we could start this. We could have a 4x here and a 4x here. That will give 16x. We could have a 2x here and an 8x, or we could have a 1x and a 16x. And you've got to go with your gut feeling here. Something's telling me that this is 4x and 4x. So I'm going to try that first. If it doesn't work out, then I'll go back to the drawing board and I'll try it with 2x times by 8x and then maybe x times 16x. So 4x and I want two numbers that multiply to give me -3. Well, I've only got a choice of -1 and 3, or 1 times -3. So we're going to have a 1 in one place and a 3 in the other. It doesn't matter which way around we put these at the moment, because we've got the 4x in both. So I know that I've got to end up with a -8, so I've not got to have a more negative. I've got to have a bigger negative in here to get that -8x. So I'm going to say the negative goes here and the plus goes here. Okay, so check in. 4x times 4x will give me 16x squared, and 1 times -3 will give me the -3. We've just got to make sure that we get a -8x. So I'm going to check that out now. 4x times 4x will be 16x squared. 4x times -3 will give me -12x. And then 1 times 4x is a plus 4x. And 1 times -3 is a -3, equals 0. Probably don't even need this equals 0 at this point. We're just checking, aren't we? So simplifying the middle bits, I've got 16x squared. Minus 12x plus 4x is -8x, which is what we wanted, and we've got the -3. So I know that that's right. So we've got our brackets there. So now I've checked that, I'm going to get rid of that. Obviously you must write further down. So from 4x plus 1, either 4x plus 1 is equal to 0, or 4x minus 3 is equal to 0. And going down a little bit, 4x plus 1, trying to solve that, I'm going to take 1 from each side. That gives me 4x is equal to -1. And then to get rid of the 4, I'm going to divide by 4. So x is equal to -1 over 4, or -0.25. And for the right hand one, 4x minus 3, I'm going to add 3 to get rid of that -3. 4x is equal to +3, +3. And then dividing by 4 gives me x is equal to 3/4, or 0.75. So my two solutions are -0.25 and 0.75. Hopefully you're happy with that. Okay. Now it's referring back now. Now we've solved that. It says find the length of BC. You must justify any decision that you make. So we've got x is -0.25 or 0.75. So back to the original page, and our solutions that we had were x equals -0.25 or x is equal to 0.75. That was the correct way around, wasn't it? Yeah. So we're looking at this now, and we're going, which one of these, which is the length of, what was the question? We had to find out the, let me just save that. We have to find the length of BC. Okay, so looking at BC, that's the one at the bottom. BC is equal to 2x minus 1. BC equals 2x minus 1. And if I choose x equals -0.25, I've got two lots of that, which is 2 lots of -0.25 is 0.5 minus 1. So it's -0.5 minus 1, which is -1.5. Well, that can't be right, because I can't have a length of -1.5 meters, so that is not correct. But if I now put in x is 0.75, so I'm going back to this one here, and I've got 2 times 0.75, which is 2x minus 1. 2 times 0.75 is 1.5. Take away 1 is 0.5 meters. So my answer for BC is 0.5 meters. Okay. Is that right? 2x. No, I've got that wrong, haven't I? What have I gone here? It's 0.75, isn't it? Not 0.5. I've made a mistake. I do apologise. Just let me go back. So I've got 2x minus 1, and I'm going to use 0.75. So x equals 0.75. 2 lots of 0.75 that right? No, I was correct. I was correct. 2 times 0.75 is 1.5. Take away 1, excuse me a minute, 1.5 take away 1 will give me 0.5 meters, and that is the length of B. I do apologise, I got a little bit confused with that one. Save. So so the answer for that is 0.5 meters. On to question 4. Okay, this has got a graph at the bottom, so we'll deal with the table first of all at the top. So the question says, the table below shows some of the values of y equals x plus 1 over x for the values of x from 0.2 to 4. And we've got to work out the value. We can see that there's only one gap here we've got to fill in. So we need to take the value 0.5 and put it into this equation. So I'm going to start off with y equals x. The x value is 0.5 and we're adding 1 over 0.5. Okay, 1 over 0.5 is the same as 1 over a half. Okay, and that is equal to 2. Okay, how many 0.5s are there in 1? Well, there are 2. How many halves are there in 1? So this is 0.5 plus 2, and the answer is 2.5. Putting 2.5 in here as my answer, and just checking the flow of this thing, because I'm expecting some sort of pattern. I've gone from 5.2 down to 2.5, then further down to 2.05, and so on. So that looks like that spot part of the pattern. It doesn't jump out as an unusual answer. On the graph paper below, draw the graph of y equals x plus 1 over x for values of x from 0.2 to 4. Now we're just going to plot on the coordinates that are given in the table. So by coordinates I mean, I'm just going to rub off the bits that I've done there. The bits that I mean here are, this was 2.5, wasn't it? I should have rubbed that off. This is one coordinate, 0.2, 5.2. So 0.2, I'm going to zoom in as I do it. 0.2, 5.2. 0.2 is 2 squares along, and 5.2 is, so it's 0.2 is there, and then 5.2 will be here. So that's the first point. Then 0.5, 2.5. 0.5 and 2.5 that will be, 2.5 will be there. And then 0.8 and 2.05, 0.8 and 2.05. 0.8 is this one here, and 2.1 would be here, so 2.05 is halfway along that square. Okay. The next one is 1 and 2, so it's a bit easier to plot that one. So we want 1 along and 2 up, which is there, and then we want 2 and 2.5. So 2 along and 2.5 will be here. And then 3 and 3.3 recurring. It's got a dot on it. So 3 and 3.3. It's a little bit, 3.3 is about there, isn't it? Just slightly above 3.3 is 3.3 recurring. And then we've got 4 and 4.25. So 4 and 4.25, it's there. It's halfway between 4 and 4.5. So I'll just scrub out the bits that are not there. Now it does say draw the graph. So whilst I've plotted the points, I haven't actually drawn the graph yet. So I need to carefully sketch in a curve. Now it's really important, difficult to do, but you've got to make sure you don't actually draw straight lines. All your points should go through all the points that you're given. So the line needs to go through every single point. Mine's a little bit out. I can see here I'm a little bit out. So try and be more accurate than that. Try and make sure it goes through every point accurately. I've done it all right apart from that one point. then it says use your graph to solve the equation x plus 1 over x is equal to 3. So we want x plus 1 over x is equal to 3. So let me just write that on. X plus 1 over x is equal to 3. Okay, so we're going to solve that. So going on my graph here, what it's saying, we had y equals x plus 1 over x, that's the curve, and we're trying to solve the graph for when that equals 3. Well, y is equal to 3 along that horizontal line there. Okay, so that is y equals 3, and so I want the intersection of these 2 points, and I want to work out what my values are when I read that down. Okay, so if your graph's slightly different than mine, you're going to get a slightly different answer. So the x value here, it's not quite at 2.5. I would say that sorry, not quite at 0.5. I would say it's about here, which is 0.45, and here it probably is on that line, isn't it? I'd say that that's about 2.6. So 0.45 and 2.6 are the x values that I would take. Okay, but it will depend how accurately you've drawn your graph and where your curves are. Question 15. A box contains 5 blue discs and 3 yellow discs. 3 discs has to be chosen at random without replacement. That means we don't put them back in the bag once we've taken them out of the box. Calculate the probability that the 3 discs chosen will all be the same colour. We could draw a tree diagram here. Okay, so each time we pull them out, we can either get a blue one or a yellow one, then a blue one or a yellow one, then a blue one or a yellow one, and that will go on all the way through like this. Okay, and same down here, blue or yellow, blue or yellow, blue or yellow, and the probabilities are going to change all the way through. Okay, so we want the probability that the 3 discs chosen will all be the same colour. So that's either blue, 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 or yellow, yellow, yellow. That's the first, the second, and the third discs. Okay, so the probability of getting a blue on the first go is 5 out of 8 discs in total, because 5 plus 3 is 8. So 5 out of 8 chance there, and a 3 out of 8 chance here. Once I've drawn out a blue one the first time, there's now only 4 blue ones left out of 7 in total that are left. Okay, and then 3 out of 7 will be yellow. Again, if I'm thinking about drawing another blue one out, I'm just going to move that out of the way so I can write in. I've only got 3 blue discs left now, and then 6 in total. So the probability of getting all blues is 5 over 8 times by 4 over 7 times by 3 over 6. Okay, and I need to multiply all that out, don't I? 8 times 7 times 6, and 8 times 7 is 56 times by 6, and 56 times 6 will give me 50 times 6 is 300, and 6 times 6 is 36, so that's 336. So it's out of 336, and 5 times 4 is 20, times by 3 is 60, so it's 60 over 336. I'm not going to cancel that down because it's not asking me to, so don't make life any harder than you need to. Going at the other end, if I drew a yellow out the first time, I've only got 2 yellows left now out of 7 discs in total. And then the next time there will only be 1 disc left in the box out of 6 discs in total. So my probability here will be 3 over 8 times by 2 over 7 times by 1 over 6 will be the same number at the bottom. This is 8 times 7 times 6 again, so it's 336 at the bottom, and 3 times 2 is 6 times 1 is 6. So the total probability will be the addition of both of these, where all the discs are the same colour. So it will be 60 over 336 plus 6 over 336, so that will be 66 over 336, and that is my answer. Okay. Next part of the question is related to the same thing. It says calculate the probability. I'm not going to use my thing here to probably extend my diagram a little bit more. Calculate the probability that exactly one disc is selected. I'm going to exactly one blue disc is selected. I'm going to use a different colour now so that I don't get confused with what I'm doing. One blue disc, well, that will be a blue one the first time and 2 yellows. It will be that one is possible. No yellow, a yellow, and a blue would be there. And a yellow, a blue, and a yellow would be there. Those are the 3 possibilities where we could get just one disc. So working it out below now because it's a bit complicated otherwise. So I need to work out all the other branches now. So for the first one, I need to work out here what that probability of getting that second yellow is. Well, if I've drawn a yellow out here and there were 3 out of 7 chances of getting a yellow, there's only 2 left out of 6 here. So that's 2 out of 6. This value here I need to work out, and I need to work out this one as well. So I've got to get a blue the second time after drawing a yellow the first time, there will still be 5 blue ones left out of 7 in total. And if I've drawn a blue one out, a yellow one out and a blue one out, then the yellow one the next time will be, there's only 2 yellow ones out of 6 left there. And then I need to work out this probability here. I'm going to have to write it down here because I haven't got a room. To get a blue there, I haven't drawn any blues out so far, so I would be 5 still left in there, 5 blues still left out of 6. So the first one will be this route here, and that means 5 over 8 times by 3 over 7 times by 2 over 6. 5 times 3 is 15, times 2 is 30. And then 8 times 7 times 6 we've already done, that's 336. And then going down the next route was to this one. We've got 3 over 8 times 5 over 7 times 2 over 6. So that's 3 over 8 times 5 over 7 times 2 over 6. And you notice this is just these two swap round. Okay, so again, that's 30 over 336. And then finally at the bottom, we've got the route here where we go that one, and that one. So that is 3 over 8 times 2 over 7 times by 5 over 6. And again, that's 30 over 336. So the total probabilities of all those put together will be 90 over 336. Quite a lot of work writing in that one. I think you just need to be very methodical and take your time with it, but you've got quite a bit of time to do that. Question 16. The following diagram shows a sketch of y equals sine x for values of x from 0 to 360 degrees. That's a full turn. Given that sine 62 is equal to 0.8829, write down all the solutions of the equation sine x equals negative 0.8829. So we've got sine 62 is 0.8829. So if I draw a line here like this across, if that's 0.82, gosh, do it a bit bigger, 0.8829, and they've said that that value there is 62 degrees. So we're going to use the symmetrical properties here, okay? We want negative 0.8829, so again I'm going to draw a line across something like that at negative 0.8829, and I'll change colours slightly here. What we could notice is if this distance here is 62 degrees, from 0 degrees to 62 degrees, then this bit here must be symmetrical with this. So that distance there must also be 62 degrees. Similarly, this distance here is also 62 degrees. So this value here must be 180 plus 62 degrees, which is 242 degrees. And this value here must be 360 degrees minus 62 degrees, which is equal to 298 degrees. So my two answers are 242 degrees and 298 degrees. Use the following axis to sketch the graph of y equals negative sine x from 0 degrees to 360 degrees. You need to probably use the previous graph to remember, but just recapping what it looks like, y equals sine x looks like this, roughly, yx. I've not put the values on, but you get the idea. It goes from 0 to 360. If it's negative sine x, what we're doing is we're making all the positive y values into negative y values. So my curve is going to look something like this. Made all the positive values negative and all the negative values positive, and it's going to look like that. You must indicate any important values on the axes. Well, that's 1 and that's negative 1. It's not particularly well drawn, that, but probably you need to make sure you show your maximums on there. Something like that, maybe. Okay, so that gives me an accurate drawing of it. Well, not an accurate drawing, but a rough approximation with labels drawn on. Use the following axis to sketch the graph of y equals sine x plus 1. Well, this is like the y equals sine x graph. Again, I'll draw that on there like that. That's y equals sine x. And we're going to add 1 to all the y values. So that means really that the graph shifts up slightly. So it shifts up. So instead of being 0 here, it goes up to here. So I'm going to start at, say, there, and the minimum value is going to go up to a 2, something like that. Then it's going to come back down to 1 here. Then it's going to go down to 0 here, and then back up to 0 there. Okay, so I've got a 1 here, back up to 1 there, sorry. So that's 1. So I'm going to draw marks on there. Those go to 180 and 360, and this value here is 2. Okay, so it's just really shifted the whole graph upwards 1 unit. I probably do need to do that as well, don't I? Just to make sure it's really clear. Okay, on to an algebra question. So, expand and simplify 4 minus root 6, 1 plus root 6. So, I need to multiply it out. So, 4 times 1 is 4. 4 times root 6 is 4 root 6. So, I want 4 root 6. Negative root 6 times 1 is minus root 6, and then negative root 6 times positive root 6. Well, root 6 times root 6 is 6, and it's a negative times a positive, so it's negative 6 or minus 6. Now grouping those together, I've got 4 minus 6, which is negative 2, and 4 root 6 minus root 6 is 3 root 6. That's expanded and it has been simplified. And simplify. We could do anything with that? No, we'll leave that as it is. We could rearrange the order of that perhaps, but I think I would be tempted to just leave it as it is. Write down an integer value of x that is greater than 5 for which x to the 3 over 2 is rational. Okay, so rational numbers. Okay, so we've got to make sure that a rational number is just a number that can be expressed as a fraction, not something like pi that is a non-recurring decimal. And an integer value would need me to an integer value is just a whole number. Okay, so we want to change that 3 over 2. So what I'm going to do is I'm going to take square numbers. Okay, so thinking about the square numbers are 1, 4, 9, 16. Okay, so the reason I'm taking square numbers is because this is cubed square rooted. The 3 at the top is cubing it, and the 2 at the bottom means square rooting. So to get rid of that square root, if I square or cube any number, I'm still going to end up with a whole number. But the fact that I'm square rooting means that I've got to have a square number to get rid of the square root, because the square root of most numbers is not a rational number. Okay, you'd be lucky. The square root of 9, fine. Okay, so to make sure that they're square numbers will help, but it needs to be bigger than 5. So 1 and 4 are out. So if I take 9 and I do to the 3 over 2, I can do, that's the same as root 9 cubed. Well, root 9 is 3, and cubing it gives me 27. Okay, so that is an integer value. So I'm writing one value down, but any would do. The answer is 9. Okay, but you could pick any square number bigger than 5. So you could carry on that sequence, but don't use either of those two. Write down an integer value of x for which that is greater than 5 for which x to the 2 over 3 is rational. Well, in a likewise way, we're going to take cube numbers here. Okay, so the cube numbers are 1 times 1 times 1 is 1, and then 2 cubed is 8, and then 3 cubed is 27. And I probably will want to think about, hang on, yeah, so any of the cube numbers bigger than 8, because it's got to be greater than 5, so 8 would work. And checking that, 8 to the 2 over 3 is the same as the cube root of 8 squared. The cube root of 8 is 2, 2 squared is 4, so that is an integer value. Okay. Okay, so write down an integer value of x that is greater than 5 for which x to the 3 over 2 and x to the 2 over 3 are both rational. Now, these have to be cube numbers and square numbers. So if I think about the square numbers, we said was 1, 4, 9, 16, 25, 36, 49, 8 squared is 64, 9 squared is 81, and then 100. I want a cube number that also is one of these now. So 1, 8, 27, 4 cubed is 4 times 4 is 16, times by 4 is 64. Hang on, 64 is a cube and a square number. That gets rid of our square root and our cube root, so the answer will be 64. But you could go higher than that, but I wouldn't go too high if I were you. tricky question that, spotting how to do that. Okay, and then we've reached the end of the paper. So at that point I would be going back and making sure that there aren't any gaps in my answers, or if you should have a bit of time left, but do your best to do that, and good luck.